Hello champions, your second PUC Chemistry Board examination is just one day away, and in this video we are going to discuss section wise the most important questions. That means first we will discuss the part B, which is 2-marker questions, then part C 3-marker questions, and then part D 5-marker questions. Okay, so let's get started with the first section, that is section B, in which each question carries 2 marks, right? So here total there will be 5 questions and you have to attempt any 3. So this section B can give you 6 marks. Okay, and now these 5 questions will be from chapter chemical kinetics, D and F block, haloalkanes, alcohols and biomolecules. So we will go chapter by chapter and see all the possible questions of 2 marker from each of this. So starting with chemical kinetics, the first question is a diagram based question. For the reaction H2 plus I2 gives 2 HI, draw the diagram showing the plot of potential energy versus the reaction coordinate to explain the role of activated complex in a reaction. So this question is there in model question paper as well. So you can say this is the diagram you have to do. So be very careful, just see the proper labeling and you have to do it. Next, write the difference between order and molecularity. This question is there in both model question paper 2 and 3. So here are some points of difference. The first of all is the definition. Order is the sum of the power of the concentration terms in the rate law, whereas molecularity is the number of reacting species colliding in an elementary step. Then possible values, it can be 0, fraction or even an integer. This is always a whole number. Next, it is determined experimentally and this is determined theoretically. It is applicable to both elementary and complex reactions. It is applicable only to elementary reactions. Next, we'll see question number 3. What is a pseudo first order reaction? Give an example. So pseudo first order reaction is that reaction which appears to be first order but actually it is a second order. Now this happens because one of the reactant is present in large excess concentration. One example you should remember: hydrolysis of ethyl acetate and inversion of cane sugar. Next, define collision frequency and mention any one factor that affects effective collisions. So collision frequency is the number of collisions per unit time per unit volume, and the 2 factors for effective collisions are activation energy and proper orientation. Next, define half-life period of a reaction and write the relation between the half-life and the initial concentration of a zero order reaction. So half-life period is the time in which the concentration of the reactant is reduced to 1/2 of its initial concentration. It is denoted by T half. And what is its expression for a zeroth order reaction? T half is equal to A naught by 2K. Next question, write Arrhenius equation and mention its terms. So K equal to A into e to the power of minus EA by RT, where K is rate constant, A is frequency factor, EA is activation energy, R is gas constant and T is temperature. Next, name the factors affecting the rate of the reaction. So here this question can be in the 2-marker section, also can be in the 3-marker section, like 2 factors can be asked, 3 factors can be asked. So nature of the reactants, temperature, concentration, catalyst, these are some of the important factors. Now we'll move to the next chapter, that is D and F block elements. So what are transition elements? Give an example. This is a question from model question paper 1. So transition elements are those elements which have partially filled d orbitals either in their ground state or in the common oxidation state. You can write any example except zinc. Next, separation of lanthanides is difficult from their natural occurrence, and study of actinoids is difficult. So this question is there in model question paper 2. Now this second question can itself be a 3-marker question as well. Okay, so I'll be telling you answer in that perspective. So first of all, due to lanthanide contraction, the change in the atomic and ionic radii of these elements is very small. Hence their chemical properties are similar, so it is difficult to separate them. Next, why study of actinoids is difficult? For that we have 3 points. First of all, they are radioactive, their half-life is very short, and they are prepared in nanogram quantities. Next, with respect to the first transition element series, which element has the highest second ionization enthalpy? The answer here is copper. Question is from model question paper 3. And lowest enthalpy of atomization, that is your zinc. Next, name the 2 main transition elements found in UK silver coins. So here you will find typically copper and nickel. Next, this question was asked in 2025 examination 3. Next, write any 2 characteristics of interstitial compounds. This was asked in 2025 examination 2. So they have high melting points, they are hard, retain metallic conductivity, and they are chemically inert. Next, we'll see 2025 model question paper. If you see, name an important alloy which contains maximum percentage of lanthanide metals and mention one of its use. So the alloy name is mic metal, okay, and it consists of lanthanum 95%, around 5% of iron and traces amount of the sulfur, calcium, carbon or aluminium, and it is used in making bullets and lighter flint. Next question, this was from model question paper 3 of 2025. Iron 3 catalyzes the reaction between iodide and persulfate ions in the reaction. Explain the catalytic activity of the catalyst iron by using the chemical reactions. Okay, so what exactly, how does iron exactly catalyze this reaction, that you have to tell. So first of all, the Fe3 plus oxidizes I minus to I2 and produces Fe2 plus. Okay, now what does this Fe2 plus do? It reacts with this S2O8 minus uh, and reduces it to SO4 2 minus, okay, or reacts with this one to form SO4 2 minus. So that is how it oxidizes. Next question is calculate the magnetic moment of Ti3 plus. This is an important question. So Ti3 plus, if you see, has D1 configuration and the number of unpaired electron is 1. So magnetic moment formula is root over of n into n plus 2, or I can say 1 into 1 plus 2, which is root over of 3, that is equal to 1.732 Bm. Next, draw the structure of manganate and permanganate ion. So these two structures you have to remember. Next, question number 10, give a reason for each of the following. So this was in 2024 examination question. The spin only magnetic moment of scandium 3 plus is 0. That is because it has no unpaired electron. Alloys are readily formed by transition metals. That is because they have similar radii and other characteristics which helps them in the formation of alloy. Next, how does MnO4 reacts with iodide ion in acidic and neutral solutions? Write the equations and write the spin only magnetic formula to calculate the magnetic moment. So if you know, MnO4 reacts differently in acidic and in alkaline medium. So MnO4 reacts with I minus in acidic medium to give you Mn2 plus, and I minus gets converted to I2. But in neutral solutions, I minus gets converted to IO3 minus and MnO4 minus gets converted to MnO2. Next question is here the spin only formula to calculate magnetic moment. It is root over of n into n plus 2. Next we have give a reason for, okay, this question we have already discussed. Next we'll move to question number 11. The transition elements are commonly known to show catalytic activity. So give reason for this. So this can be 2 reasons or even 3 reasons. So you should be knowing all the 3 points because it can be asked either in the 2 marker or in the 3 marker section. So first of all is variable oxidation state, large surface area and presence of incompletely filled d orbitals. Next is transition elements are known to form complex compounds. The reasons for that is smaller size, larger ionic charges and availability of vacant d orbitals. Now moving to the third chapter, that is haloalkanes and haloarenes. The first question is on SN2 mechanism, chloromethane to methanol. So you have to draw the structure here. Here a transition state is formed. Next, Swartz reaction with an example. So here you know alkyl chlorides and alkyl bromides are converted to alkyl fluorides in presence of metallic fluorides. So you have to write the statement and the reaction. Next, what are optically active compounds and give the condition for the molecule to be optically active. So optically active compounds are those compounds which can rotate the plane polarized light when it passes through the solution. Now what is the condition for optical activity? It should either it should be chiral, means it should have non-superimposable mirror image. It must contain at least one asymmetric carbon and there should not be any plane of symmetry. Next is explain fatigue reaction with suitable examples. So this was asked in your 2025 exam 2 and 3 both. So fatigue reaction when aryl halides reacts in presence of sodium and dry ether to give diphenyl, we call it as fatigue reaction. Next, what is Wood's reaction? So in Wood's reaction, what happens? Alkyl halides reacts with sodium and dry ether to give hydrocarbons containing double the number of carbon atoms present in the halide. So when you have Rx and it reacts with sodium and dry ether, you will get RR plus NaX. Okay. Next is chlorobenzene cannot be prepared by reacting phenol with SOCl to give reason. So this was there in 2025 second model question paper. So chlorobenzene cannot be prepared from phenol by using SOCl2 because the CO bond in phenols, okay, has a partial double bond character. That's the first reason, and therefore the OH group is not easily replaced by chlorine. Next, Seitzef rule and name the major product formed when 2-bromobutane undergo dehydrogenation. So Seitzef rule says that in dehydrohallucination, the preferred product is that alkene which has greater number of alkyl groups attached to it, and the product of 2-bromobutane, the major product will be but2-ene and not but1-ene. Next, write the IUPAC name of the product obtained when ethyl bromide reacts with sodium iodide in dry acetone. Name the reaction. So iodoethane will be produced and the name of the reaction is Finkelstein reaction. Next, complete the following reaction: CH3Br with KCN. This will give you CH3CN, and C2H5Br with COF2. This will give you C2H5F. Okay. Next, alcohols, phenols, and ethers. Write the products formed when anisole reacts with ethanol chloride in the presence of anhydrous AlCl3. So this is Friedel-Crafts acylation reaction. And when anisole is a orthopara directing group, so when it reacts, you will get 2-methoxyacetophenone and 4-methoxyacetophenone. Next, what is Lucas reagent and which class of alcohols does produce turbidity immediately with it? So Lucas reagent is the mixture of concentrated HCl and anhydrous ZnCl2. And which class of alcohols immediately produces turbidity? That is your tertiary alcohols. Next, classify anisole and methoxymethane into simple ether and mixed ether. So if you see, anisole structure is like this. Okay, OCH3. Now here you can see two different groups are attached around O. So this is your mixed ether. And you have another one is which is the methoxymethane, that is CH3OCH3. Now here you can see both the groups are same, so this is a simple ether. Next is, how do you convert isopropyl benzene into phenol? This is important question. Write its equation. So cumene, which is also called as isopropyl benzene, is oxidized in the presence of air to cumene hydroperoxide, which is converted to phenol and acetone by treating it with dilute acid, and this is the reaction. Next, while separating a mixture of ortho and para nitrophenols by steam distillation, name the isomer which will be steam volatile and give reason. So ortho nitrophenol will be steam distilled. It is because it has intramolecular hydrogen bonding and not intermolecular hydrogen bonding. Next, complete the following reaction and name the reaction. So here the product will be benzaldehyde, CHO will be attached, and the name of the reaction all of you might be knowing, this is Reamer-Tiemann reaction. Okay. Next, explain the preparation of methoxyethane by Williamson ether synthesis and give equation. So methoxyethane, so in Williamson you'd have to take one alkoxide ion and one haloalkane, right? So if you react sodium methoxide with ethyl bromide, then you will get methoxyethane. This is the reaction. Next is, after that there are certain name reactions that you should definitely prepare: Coles reaction, Reamer-Tiemann reaction, and Williamson ether synthesis from this particular chapter. Moving to the next chapter, that is your biomolecules. Name the hormone that is released rapidly due to the rise in blood glucose level to keep the blood glucose level within the narrow limit, and mention the number of amino acids present in this hormone. This is model question paper 1 question. So the hormone is insulin and it has 51 amino acids. Next, model question paper 2, write the example for essential amino acids and fibrous proteins. So essential amino acid, valine, leucine, lysine, you can write any one. Fibrous protein, keratin, you have collagen is there, any one you can write down. Next, we'll see model question paper 3, identify the proteins and give any one difference between these proteins: the protein present in the hair and the protein present in the egg albumin. So first you have to identify and write one difference. So the protein present in hair is keratin, which is a fibrous protein, and the protein present in egg albumin is actually ovalbumin, or you can simply write albumin, which is a globular protein. What is the difference between them? Keratin is insoluble in water, whereas egg albumin is soluble in water. Next, what are non-essential amino acids, and name an optically inactive naturally occurring alpha amino acid. So this was in 2025 paper. So non-essentials are those that are that the human body can synthesize on its own and do not need to take it from the diet. Example of an optically inactive amino acid is glycine. Next, draw the Harvard structure of lactose. This is the structure, very, very important. Okay, similarly, you should also prepare for sucrose and maltose structure. Okay, we will discuss it in the future questions as well. Name 2 fat storing tissues found in the human body that stores fat soluble vitamins. So your adipose and liver. Next, we have give an example of female sex hormone and write its function. So example is estradiol, and it is used in the development of secondary female characteristics and participate in the controls of menstrual cycle. Next, what are hormones, and name a hormone that mediate response to external stimuli. So hormones are the chemical messengers produced by endocrine glands directly into the bloodstream to regulate different physiological processes, and the hormones which are responsible for external stimuli are your epinephrine and norepinephrine. Next, what are the write the reactions in the glucose that tells you 5 hydroxyl groups and an aldehyde group is present. So for 5 hydroxyl group, the reaction with this one, that is acetic anhydride, and for aldehyde group the reaction is with bromine water. Next, we have name two hormones which regulate the glucose level in blood. So that is insulin and glucagon. Write any two nitrogenous bases found in both RNA and DNA, adenine, guanine, and cytosine. And what is the function of the following hormones in the body? Insulin and epinephrine. Insulin maintains sugar level and epinephrine responses to external stimuli. Okay, now we will move to section C, 3 marker question. So if you know that, so now let's start with the section C, that is 3 marker question. So if you know, in 3 marker questions, there are first 5 questions are from inorganic chemistry. So here you will get total of 5 questions, out of which you have to attempt any 3. And in this 5 questions, 2 will be from DNF block and 3 will be from coordination compounds. So we will be discussing the 3 marker questions from DNF block as well as from coordination compounds. So let's start with the first question of DNF block. Very, very important question. What is lanthanide contraction, and mention its consequences. It was asked in model question paper 1 as well. So the gradual decrease in the atomic and ionic radii of lanthanides from lanthanum to lutetium with the increasing atomic number is called as lanthanide contraction, and it is due to the poor shielding effect of 4f orbitals. The consequences are zirconium and hafnium have similar size. Separation of lanthanides is difficult. One more you can write is basicity decreases along the period. Okay, basicity along the period decreases. Next question is complete the following reaction. So this is from the model question paper 1 only. So this is, if you see, in the preparation of potassium dichromate, this first reaction is used. So here it is FeCr2O4, that is iron chromate. Then MnO2 undergoes fused with KOH and it gets converted to K2MnO4. Next, we have KMnO4 is heated at 513 to give you K2MnO4 plus O2 plus MnO2. Okay. Now we'll see question from model question paper 2. Explain the preparation of potassium permanganate from MnO2 with the balanced equation and mention the gas evolved when KMnO4 is heated. So you can see this is the reaction. First of all, MnO2 is fused with KOH and O2 to give you K2MnO4, and then K2MnO4 undergo hydrolysis to give you KMnO4. And when KMnO4 is heated at 513 Kelvin, the gas released is oxygen. Next, we have considered the elements of 3D transition elements. Write the element which is unable to form a monooxide. It is your scandium. Next, having positive inert value is copper. A base element of Ziegler-Natta catalyst is your titanium. Okay, this question is also there in model question paper 2. Now we'll move to model question paper 3. Write the balanced equation for the preparation of potassium dichromate from chromite ore. So first of all, iron chromite is taken. It is converted to sodium chromate. Sodium chromate is converted to sodium dichromate. Sodium dichromate is converted to potassium dichromate. Next, write the formula of 3 different types of compounds formed when lanthanides react with carbon heated with carbon or heated with carbon. So you'll get LnC2, Ln2C3 and Ln3C. Next, we have 2025 examination 1. What is lanthanide contraction? And write one comparison and one difference between the lanthanides and actinides with respect to the oxidation state shown by them. So what is lanthanide contraction? We have already discussed. Comparison or similarity in oxidation state is both of them show a stable +3 oxidation state. And what is the difference? So lanthanide can show +3 oxidation state and sometimes +2 and +4, but actinide shows a variable oxidation state like +3, +4, +5, +6 and +7 as well. Okay. Next is calculate the magnetic moment of Fe2 plus by using the spin only magnetic formula. So I'll solve this here. So if you know Fe2 plus has a configuration of D6, that means the number of unpaired electron is 4 here. So the magnetic moment will be root over of n into n plus 2. So that will be root over of 24, which is equal to 4.89 bm. Okay, next, this is answer for A. Next is write the compare equation for the reaction of lanthanoids with oxygen. Okay, so when lanthanoids reacts with oxygen, we get Ln2O3. Okay, so if I want to balance it, you can take here, I think, yes, you have to take 4 Ln and 3 O2. Okay, Next is give reason for the following. So this was there in 2025 examination too. Why zinc is colorless? So that is because it has no unpaired electron. Cerium shows +4 oxidation state. That is because it has 4f0 stable configuration. Zr and HF exhibit similar radii. That is because of lanthanide contraction. Next, name two trivalent lanthanoid ions that are colorless. So lanthanum plus and lutetium 3 plus. Next, what type of lanthanide compounds are employed as catalyst in petroleum cracking? So lanthanide oxides are used in petroleum cracking. Next, we will see questions from coordination compounds. So this is 3-marker coordination compounds question. So first of all, what is Werner's theory? Its postulates, very important. It shows two types of valency, primary and secondary valencies. Primary valencies are normally ionizable and are satisfied by negative ions. Secondary valencies are non-ionizable and are satisfied by neutral molecules or negative ions. Next question is using VVT explain the shape of COF63 minus. So already I have done this in the passing package video as well. So first of all, you have to write the oxidation state, then the electronic configuration. Fluorine is a weak field ligand, so no pairing of electron takes place. So this sp3d2 undergoes hybridization to give you 6 sp3d2 hybrid orbitals in which the fluorine can give its electrons. Okay. Next, we will see question number 3. So similarly, here you can find this type of question can also be asked for CONH3 whole 6 3 plus, can be also asked for NiCN4 2 minus and NiCl4 2 plus. Okay, so in all this case 2 minus also here also. Yeah, so in all this case you have to write it in this particular format only. Next, d orbital splitting, T2G and EG splitting will be there. And what is spectrochemical series? The arrangement of ligands in a series in the order of the increasing field strength is called as spectrochemical series. Next, we have coordination compounds based on the crystal field theory. Write the configuration of D5 when delta O is less than P and delta O is greater than P. Now, when delta O is less than P, that means it is a weak field ligand. So the configuration here will be T2G3 EG2, and the splitting is high, their pairing will take place. So the configuration will be T2G5. What is pairing energy? So pairing energy is the energy required to pair two electrons in the same orbital. Next, write the formula and structure of octacarbonyl dicobalt. So this is the structure of octacarbonyl dicobalt. How many bridge carbonyl ligands are present? We have 2 bridge carbonyl ligands. Next, with the help of the structure, explain the synergic effect in metal carbonyls, how it affects the MCO bond strength in such compounds. So first of all, you can see this diagram you have to draw, and then you have to write down how the sigma bond is formed, how the pi bond is formed. So the sigma bond is formed due to the donation of lone pairs of electrons on the carbonyl carbon into the vacant d orbital of the metal. And the pi bond is formed because of the filled d orbital of the metal into the pi star antibonding orbital of the CO group. Okay. Next, we have heterocyclic complexes with coordination number 6. Okay, sorry. Shows geometrical isomerism. A complex Ma3B3 shows geometrical isomerism if the central atom M has a +3 oxidation state. Predict the denticity and draw the structure of two geometrical isomers of the complex and name them. Okay, so first of all, predict the denticity. If there is, you can see that coordination number is 6 and the formula is also there are 6 ligands, so definitely the denticity is equal to 1 here. Okay, now you have to draw both the isomers. So Ma3B3 has facial and meridional isomerism. So the formula here is, you can take anything like CONH3 whole 3 Cl3. So we have 6 structures like this, right? So when you put just a minute, if you put the same ligand, so I'm just writing Ma3B3. So if I write A here and B and B here, this is called as facial. Okay, and if you have like this structure and you write A and A here and B and B here, then it is meridional. Okay. Now next, how many square pyramidal units are present in dodecacarbonyl dimanganese? Okay, so write its molecular and structural formula. So you can see here I have decacarbonyl dimanganese. So the formula here is Mn2CO10. Okay, write its molecular and structural formula. So this is the molecular formula and the structural formula is like this. You have Mn and CO 1 2 3 4 and 5. Similarly, here 1, 2, 3, 4 and 5. Okay, so how many square pyramidal units are there? 2 square pyramidal units are there. Next, write the geometric isomers of the complex given like this, which among them is chiral. So if you draw the geometrical isomers, you will have one cis and trans. So first of all, if I draw the, I can say cis one. Okay, sorry, I'll draw like this. So this is the cis one. Okay, and the trans one will be like this, where I have Cl on the axial positions and you have En on the positions like this. Okay, so this is the transposition. So you have done two geometries, and which among them is chiral? The cis one is chiral. Next, Alfred Werner, a Swiss chemist, formulated his revolutionary ideas about the structure of coordination compounds. When a compound COCl3.6NH3 is heated with excess of AgNO3, 3 moles of AgCl was formed. That means 3 chlorine was outside. Based on the observation, write the formula of the compound. So this is very easy. We can write down the formula like this: CONH3 whole 6 Cl3. Mention the primary and the secondary valency of the central metal atom. So here the primary valency is definitely +3 and the secondary valency is 6. Next, okay, on heating COCl3.4NH3 with excess of AgNO3, 1 mole of AgCl is formed. Okay, so 1 chlorine will be outside. Formula of the complex and write its geometrical isomer. So if I write the formula of the complex, it will be CONH3 whole 4 Cl2 and 1 chlorine is outside. Okay, formula of the complex is written and its geometrical isomers. CO, I have Cl, I have Cl, NH3, NH3, here I have NH3 and here I have NH3. Okay, so this is the transform, and when I have cis form, it will be like this. This will be the structure formed. Okay, so students, now we will be discussing the section C 3 marker questions from physical chemistry. Okay, so here if you see, total there will be 4 questions, out of which you have to attempt any 2. And how the questions are distributed: 1 question will be from solutions, 1 question will be from kinetics, and 2 questions will be from electrochemistry. Okay, so let's get started with the first question of solutions, 3 marker section. So name the concentration term which is commonly used in medicine and pharmacy. Write the definition and the mathematical equation for that concentration term. It was asked in model question paper 1 of this year. So the concentration term that is commonly used in medicine is mass by volume percentage. And what is its definition? It is mass of the solute present in 100 ml of the solution and its mathematical expression. Next is from model question paper 2. Write 3 reasons to justify that osmotic pressure method has the advantage over other methods. So the first one is it uses molarity instead of molality. Second, the reaction or this observation can be done at a room temperature. And the third one, as compared to other colligative properties, it gives you large value even for dilute solutions. Next is from model question paper 3. Given below is a sketch of a plant for carrying out a process. Name the process occurring in the given plant. So that is reverse osmosis. Name the semi-permeable membrane used here, that is cellulose acetate. And give one practical use of the plant, that is desalination of seawater. Now we will see 2025 examination 1 question. Define azeotropes. What type of azeotropes are formed by the solution with negative deviation from Raoult's law? Give an example of it. So I have given this question some other important answers as well. So what are azeotropes? First of all, binary liquid mixtures having the same composition in the liquid and vapor phase and boiling at the constant temperature are called as azeotropes. Now, what type of azeotropes formed by the solutions with negative deviation? They form maximum boiling azeotrope, and for them example is your nitric acid and water. But the question can also be asked in the form of the difference between minimum and maximum boiling azeotrope. So in that case you can read this answer as well. So prepare this also, it is important. Next, 2025 examination 2, state Henry's law, write its mathematical formula. What is the effect of pressure on the solubility of solid in liquid? Henry's law we have already seen a lot of times, and the pressure in the solubility of solids in liquids has no effect. Next question is from 2025 examination 3. What are colligative properties? And the name the colligative property expressed in terms of mole fraction and write its mathematical equation of that colligative property. So first of all, those properties which depend on the amount of solute and not on its nature is called as colligative property. The colligative property which depends on the mole fraction is relative lowering of vapor pressure, and the formula for that is delta P by P naught is equal to XB, or we can expand it to write like this: P naught minus P by P naught is equal to XB. Okay. Next is difference between ideal and question is difference between ideal and non-ideal solution. So this at least 1, 2, 3, 4, 5 points of difference are there. You can prepare any three, but yes, examples are very, very important. So do remember the examples here. Now the difference between positive and negative deviation can also be asked in the examination. So here also you have 1, 2, 3, 5 points. Okay, but yes, example you have to definitely write down. Okay, these are two important difference between that you should prepare. Next is from 2024 examination 1, explain reverse osmosis and write one of its application. So when you explain it, this diagram is mandatory. So explanation and diagram will carry 1 mark and its application carries 1 mark. So the direction of osmosis can be reversed if a pressure larger than the osmotic pressure is applied on the solution side. That is, now the pure solvent flows out of the solution through the semi-permeable membrane, and this is called as reverse osmosis. You can draw this diagram here, and its application is in the desalination of water. Next we have what is meant. Okay, now we are moving to the next chapter, that is chemical kinetics. So the first question of was in the model question paper 2. Here I have taken what is chemical kinetics and write its two application. So chemical kinetics is that branch which deals with the study of the reaction, conditions in which the reactions takes place, and the mechanism of chemical reactions. It helps to determine the speed, describe the conditions in which the reaction rate can be altered. Next question is from model question paper 3. Derive an integrated rate equation for the 0th order reaction. So first you have to assume let R gives you P, then rate is equal to minus dr by dt. Rate is also equal to K into R naught. So you will get this equation. Then you have to take the integration on both sides, and after this integration find the I value and then substitute, and you will get this answer as the final answer. Next, in 2025 examination 3, derive the integration rate law for first order equation. So similar only, but yes, here the equation will be slightly different. Final answer will be this one. I think derivation we have discussed a lot of times. Here the main purpose is to just discuss the question, so I hope you can go through this derivation. Next question is from your examination. I think this was 2025 examination 3. This is from your model question paper. Okay, one of the model question paper. I guess it is model question paper 1 of this year. So R gives you P, the potential energy diagram is there. What is the value of activation energy? So if you see, this value is your activation energy from the reactance energy to the threshold energy. So that is equal to 40 kilojoule. Okay, next, what is the value of delta H? Okay, so delta H value will be what? This difference. So energy of the reactants, energy of the products minus energy of the reactants, so that is your minus 15. Next, draw the potential energy diagram for P to R reaction if it is happening. Okay, so if I want to draw this reaction, you can see here. So if I want to draw from P to R, so it will be an endothermic reaction. So energy of P is 5. Okay, and the energy of R is 20. Okay, this is R here, and this value will be 20. Now what is the activation energy from this side? If you see, activation energy is actually, you can see from here 60 to 5. So this gap is their activation energy, which is 55, right? So that is why this activation energy will be here 55. That is what you have to draw here. Next question is what are P and ZAB represents in this equation, and name the factor on which Z depends. So P represents your steric factor and Z represents collision frequency, and it depends on the temperature. Next, we have derived the integrated rate law for gas phase reaction. This is important question, less asked. It was asked in the last year pre-board examination. So definitely this question you should prepare. How to derive this equation, I have already explained it. So I'm not going to explain it again here. Please go through this derivation. Now moving to the next chapter, that is electrochemistry. The first question, model question paper, is the discussion of 3 types of materials based on conductivity. So we have conductors, which are very good, semiconductors, which can conduct in between conductors and insulators, and then we have insulators here. Next is the diagram shows that when iron is exposed, so there's a diagram here. So name the phenomenon here, that is corrosion, and write the atmospheric oxidation of iron. Okay, here oxidation is actually, yeah, so you have to write Fe gives you Fe2 plus 2 electron. Okay, that is the reaction you have to write down, and this is the reduction reaction. Mention only one method to avoid this phenomenon. You can write down painting, greasing, galvanization. All these techniques can be used. Next, what are electrochemical cells, and mention it two types. So device which converts chemical energy to electrical energy by a redox reaction, and type of galvanic cell is type of electrochemical cells are galvanic cell and electrolytic cell. Next, three factors on which the products of electrolysis depends: nature of the electrode, nature of the electrolyte, and concentration of the electrolyte. Next, we have model question paper 3. Give an example of inert electrode and write the representation of half cell reaction for bromine. So first of all, platinum or gold electrode are inert electrode. A representation of bromine is Pt with Br2 and Br minus. The reduction half cell, if you want to write for bromine, reduction part, it will be Br, like 2 Br minus. We lose, reduction. Okay, one second. We have to write the reduction reaction. So it will be like this: Br2 plus 2 electrons give 2 Br minus. And oxidation is like this: 2 Br minus loses 2 electrons to give you Br2. Next, write the overall nickel cadmium battery reaction. So you can see here how cadmium and nickel gets oxidized and reduced. The whole reaction is important, so remember this one, important question. Now we will move to 2025 examination 1. Write a neat level diagram for cell representation and half cell reaction of standard hydrogen electrode. So first of all, this diagram you have to do. Then you have to do cell representation is this one. Then the half cell reaction. So half cell reaction is like 2H plus 2 electrons gives you hydrogen gas, and this is aqueous medium. Okay, next is lead storage battery. What is a secondary cell? And write down the reactions that occur at anode and cathode during the discharging of the lead storage battery. Okay, so what is a secondary cell? It is a cell that can be used by recharge by passing the current in the opposite direction, so that can be used again. Now during discharge, what happened? Anode, in that Pb gets oxidized to Pb plus 2, and in cathode PbO2 gets converted to PbSO4. Next, we will see 2025 examination 2. What is molar conductivity, and write its SI units, and how much electricity is required to convert FeO to Fe2O3. So molar conductivity is the conductance of 1 mole of an electrolyte, and its unit is S meter square mole inverse. And here oxidation of Fe takes place from plus 2 to plus 3. So 1 mole of electron is required, but there are 2 Fe, so total 2 Faraday will be required. Next is cathodic and anodic reactions of the fuel cell. So first of all, draw it. Then cathodic reaction, H2 undergoes oxidation, O2 undergoes reduction, and then overall reaction. Next, we have question, explain the Faraday's law, first and second law. So first law is the amount of reaction is based on the amount of electricity passed. So statement, you have to write it correctly, and then the formula. And Faraday's second law, when the same quantity of electricity is passed through different electrolytes, the masses of the substance deposited are proportional to their equivalent weights. Next, we have rusting of iron as an electrochemical phenomena. So this particular mechanism of corrosion, you have to remember that the statement, especially the anode cathode reaction and the overall reaction here is important. Now we will move to next one, difference between electronic and ionic conductance. So here I have given the difference. You can remember any 3 to 4 points. Next is, we'll move to section D, organic chemistry. So here we have 5 chapters: haloalkanes and haloarenes, alcohols, phenols, ethers, aldehydes, ketones, carboxylic acid, amines, and biomolecules. So here in section D, there will be total of 6 questions. Okay, there will be 6 questions, out of which you have to attempt any 4, and each question 4 into 5 will give you 20 marks. So there will be 1 question from haloalkanes and haloarenes, 1 question from alcohols, phenols, and ethers, 2 questions from aldehydes, ketones, 1 question from amines, and 1 question from biomolecules. Okay, so let's see the questions chapter by chapter now. Haloalkanes and haloarenes, here definitely one of the question is SN1 and SN2 mechanism. So the first question is, when alkyl chlorides are reacting with sodium iodide in dry acetone, it gives alkyl iodide. Name the reaction. Okay, so if you know, this name of the reaction is Finkelstein reaction. Next, we have what is the general equation. So if you take Rx plus NaI, okay, with dry acetone, that will give you Ri plus NaX. Now, what is the role of dry acetone? So NaCl and NaBr thus formed is precipitated. So whatever this NaX NaCl is formed, its precipitation is taken care of by dry acetone, so it is important. Next is what is racemic modification, and they are optically inactive. Give reason. So the mixture which contains equal amount of both the enantiomers is called as, like, both the enantiomers of an optically active compound in equal amount. Those type of solutions are called as racemic modification. And why they are optically inactive? Because if the dextrorotatory enantiomers rotate it in clockwise direction and like to the left by the same magnitude, and the other one will be rotating it in anti-clockwise direction in the same magnitude, so the net rotation cancels each other and is equal to 0. So that is why it is called as optical activity is 0 here. Next is model question paper 2 question. Give two difference between SN1 and SN2. Here you can see the difference between SN1 SN2 on basis of these 3 points. Next, explain fatigue reaction. So name reaction is important. Here aryl halides are converted into diphenyl. Next, we'll see the question from model question paper 3. Here again fatigue reaction. We have already explained this, discussed this question. Mechanism of conversion of methyl chloride to methanol. So this is your SN2 mechanism, one step reaction. Here a transition state is formed. How many stereo centers are present in butane 2-OL? So if you see the structure of butane 2-OL, there is only one chiral carbon, so that is one stereo center. Now we will move to question of 2025 examination. Write SN2 mechanism for the conversion of chloromethane to methanol. Mention its order. So already the mechanism carries 2 marks, and if you write its order, okay, so it is a second order reaction. So it is the order of the reaction, second order reaction. Next, what is racemic mixture? That we have already discussed. And how do you represent butane 2-OL in racemic mixture? So because both the enantiomers are present, so you will write plus minus butane 2-OL. Okay. Next, we will see 2025 examination 2 question. Aryl halides are less reactive than alkyl halides. Give any 3 reasons for this one. So this will carry 3 marks. Resonance effect, hybridization of carbon, and instability of phenyl carbocation. Next, what is the general equation of Finkelstein reaction? What is the role of dry acetone in that? So general equation, we have Rx plus NaI gives Ri plus NaX. And here we have used dry acetone. Okay, now NaCl or NaBr thus formed is precipitated in dry acetone. It facilitates the forward reaction according to the Le-Chatterley principle. Now we will see 2025 examination 3 question. Write the mechanism of SN1 reaction. So mechanism of SN1 carries 2 steps. Mention the reactant on which the rate of the reaction depends. So 2 steps carries 2 marks, and writing the reactant on which the rate of the reaction depends, that is your 1 mark. So total 3 marks you will get. So these are the 2 steps. The step 1 is the formation of carbocation, and the second step is the attack of the nucleophile. Okay, next, this is 3 marks, and the reactant on which the rate of the reaction depends, that is on the substrate, that is tert butyl bromide. Next, explain Sedgwick rule and with a suitable equation. So Sedgwick rule tells that in dehydrohallucination, more substituted alkene is the major product, and you can write down any one example. So now let's move to the next question. Write the 3 steps involved in the acid catalyzed dehydration of ethanol to ether. So here this mechanism is generally less asked, but yes, it is there in your model question paper, so definitely prepare it thoroughly. So first of all, there's protonation, and then there is attack, and then there is deprotonation. Next is Cole's reaction with an example. So you have to write the statement and then the reaction completely. Next, there's one more mechanism, acid catalyzed dehydration of ethanol to ethene. So this can be a 3-marker question very easily. So first step is your protonation, then you have elimination of water, and then you have deprotonation. So prepare this mechanism is more important. Okay. Next one, we will see how is salicylic acid prepared from phenol, explained with an equation. So this is the same Cole's reaction. So the same we have already discussed. Alcohols are comparatively more soluble in water. That is because of their ability to form intermolecular hydrogen bonding. Next is model question paper 3 question. Write the steps involved in the acid catalyzed dehydration of ethanol to ethene. So this we have already discussed. And Na2Cr2O7, this is oxidation. So you will get benzoquinone as the major product here. And OH with 3Br2. So here there will be 2,4,6 tribromophenol. Okay. So you will get OH here. Then you will have 2, and at that 4 position, and then at the 6 position. Next, we will see what is Lucas reagent and how it is used to distinguish between 3 classes of alcohols. So first of all, Lucas reagent is a solution of anhydrous zinc chloride in HCl, and how it is used to separate primary and tertiary alcohols. Okay, so this question was there in 2025 examination 1. So tertiary alcohols react immediately and creates turbidity immediately, whereas primary alcohols do not react, so there is no turbidity. Next is about Williamson ether synthesis. So in Williamson ether synthesis, haloalkanes reacts with alkoxide ions to form ether. So that is the reaction you have to write down. Next, we have examination 2 question. Write the steps in the acid catalyzed dehydration of ethanol to ethene. This we have already discussed. OH with 3Br2, this also we have discussed. So this one will give you what I'll say 2,4,6 tribromophenol. Next we have C2H5Br plus C2H5ONA. So this is actually, this one will be what I'll say Williamson ether synthesis. So you will get C2H5OC2H5. Okay. Next we will move to 2025 examination 3 here. So the first question is acid catalyzed hydrolysis of ethene to ethanol, means formation of ethanol from ethene. So first of all, there is protonation, okay, and you get a carbocation here, and then there is an attack of nucleophile, and then we have deprotonation here to get alcohols. So between paranitrophenol and paracresol, which has highest pKa and least pKa values, so the one which is, so paranitrophenol is more acidic, so it will have least pKa value, okay, and paracresol, it has a CH3 group which is the electron donating group, so it is least acidic, so it will have highest pKa value. Next, we will move to the chapter aldehydes, ketones and carboxylic acid. The first question from model question paper 1, right, mention the name of the following reaction. So this one is your Rosenmond reaction, right? Next, we have RCOCl. This is your Friedel-Crafts acylation reaction, Friedel-Crafts acylation. And next we have the ZnSG and HCl. This is what? This is Clemmensen reduction. Clemmensen reduction. Now, among methanol and ethanol, which one undergoes Cannizzaro reaction? Give reason. Okay, so out of these two, methanol will undergo Cannizzaro reaction, and what is the reason for that? Because it has no alpha hydrogen. So that's all in the first paper. Now from this chapter you will get 2 questions. So model question paper 1, second question from this chapter is a word problem based question. So there is a compound A with molecular formula C7H8. So whenever you see the number of carbons is more than 6, there is a high probability that it is benzene, okay, and it is heated with alkaline KMnO4, alkaline KMnO4 followed by acidification to give compound B of the molecular formula C7H6O2. Now this compound B turns blue litmus red, that means this is acidic in nature. Okay, now the sodium salt of compound B is heated with reagent X. Okay, so the sodium salt of compound B is heated with reagent X to give a hydrocarbon C of molecular mass 78 gram per mole. So from that you can easily guess that it is benzene. So identify the structures of A, B and C. So I can easily guess here A is nothing but toluene. Okay, then when you heat it with alkaline KMnO4, you will get here COOH. Okay, and then alkaline KMnO4, you will get COO minus and K plus. Now when you followed by acidification gives you compound B. So after acidification means you are heating it with first alkaline KMnO4, okay, and then you are acidifying it. If you are doing acidification, then the final product is COOH. So here the product is COOH. Then we have sodium salt of this compound, that is COONA. Okay, sodium salt of the compound B, okay, is heated with a reagent X. What is the reagent here? NaOH plus CaO, the soda lime, which will undergo decarboxylation to give you a compound this which is benzene. Okay, so we have identified this is A and this is B and this is C. Now identify X and mention its role in the reaction. So X is nothing but soda lime, and what is its role? It is used for decarboxylation. Decarboxylation. Okay, now moving to the next one, question number model question paper 2 we have. So when you treat CH3 MgBr dry ether with H3O plus, okay, so in that case, if you take it in presence of acidic medium, first of all you will get here, that is CH3 MgBr plus A is there, and then you are treating it with dry ether and CH3O plus. So this has to be carbon dioxide. Okay, so if you take carbon dioxide, here you will get CH3COOH. So you have to be very careful. You can see that the next reagent which is used is for HVZ reaction. So that means here there should be one acidic group, and if you treat this one with carbon dioxide, then only you will get the acid. And next we will get CH2Cl COOH. Okay, so A we have identified, B we have identified, and C also identified. Name the reaction for the conversion of B to C, that is your HVZ reaction or Hell-Bollard-Zelinsky reaction. Now compound C is more than acidic than compound B. Give reason. So that is because compound C has a chlorine group which is an electron withdrawing group. So you can see just 1 mark question, you can just write this much. Next we will see the second question of model question paper 2. Provide the general reaction to prepare halofrom from methyl ketones. Name a reagent which is used to detect the presence of alpha methyl in the carbonyl compound. So haloform reactions are those where aldehydes or ketones having one methyl group is linked to a carbonyl carbon, that is called as methyl ketone, are oxidized by sodium hypohalite to form the salts of carboxylic acid, and can also react to give you one like the salts of carboxylic acid which is formed is having one carbon less than the original reactant. Okay, the methyl group is converted to haloform. Now the one which is used to identify is NaOI, because here when you form CHI3 iodoform, that is a yellow precipitate and can be easily detected. Next is, so here you will write down this explanation, write down this reaction, and this NaOI will give you 3 marks. In a given reaction, write the structure and the name of the compound Z. Okay, so here it is 2,4-DNP actually. So this one will be NH2, then you have N, H, and then you have this one NO2, NO2. Okay, and what is the name of this compound? So it is 2,4-dinitrophenyl hydrazine. Okay, now we will see next one, model question paper 3. Identify compound A, B, and C in the following reaction. So in cadmium, what happens? This Cl group will be replaced with CH3. So I'll get CH3CO CH3. Now NaOI, just now we discussed, one of the group will break and will get converted to CHI3, and the other group will be converted to CH3COO minus Na plus. Next is an organic compound P, which is C7H6O2, reacts with thionyl chloride. So you have C7H6O2. Okay, sorry, an organic compound P reacts with thionyl chloride, SOCl2, to give a product Q. Now Q on further undergoes hydrogenation in the presence of H2 and palladium barium sulfate to form a compound R. Now write the equations involved in the chemical reaction. So C7H6O2, when you have, so we have one carbon here, COOH. Okay, so this is there. When I treat it with SOCl2, then what I will get? I will get here a compound like this, C double bond O Cl, and then when you treat it with hydrogen palladium barium sulfate, you will get C double bond OH. Okay, next we'll see model question paper 3, second question. Explain HVZ reaction. So that is the statement of HVZ reaction, and then you have to write the reaction properly. Very important question. Next, write the reaction of conversion of toluene to benzaldehyde using chromial chloride. So that is your Itard reaction. So name of the reaction is Itard reaction, and the question is asking you to only write the reaction. Okay, so in that case this explanation part is not required, only the reaction will work, and this reaction and the name of the reaction will give you 2 marks. Next is name the gas used to facilitate the nucleophilic addition reaction, that is dry HCl gas, which is used to increase the electrophilicity of the carbon. Next we will see 2025 examination 1 question, mechanism of addition of HCN. So this is the first is the generation of nucleophile, then CN attacks on the electrophilic carbon to form a tetrahedral intermediate, which in acidic medium gives you the final cyanohydrate. Next, explain Rosenmond reaction with the chemical reaction. So first of all you have to write the statement of Rosenmond reaction and then the reaction. This carries 2 marks. Next question was, okay, there's a what I'll say, this is also from your 2025 first exam paper. So this is a what we call it word problem based question. So an organic compound A On treatment with ethanoic acid in presence of hydrochloric acid gas as a catalyst produce an ester B. Okay, so if an organic compound A is there which is reacting with ethanoic acid to give you a compound B which is an ester. Now we can easily figure out that if this is ester, then this must be one alcohol group. Okay, now A on oxidation with CrO3 in anhydrous medium gives you C. So if this one is treated with CrO3, it gives you C. Now C is heated with concentrated KOH. C is heated with concentrated KOH followed by acidification with dilute HCl to give you A and D. So you can easily guess that this is which reaction? This is Cannizzaro reaction, right? So that means this has to be a aldehyde with no alpha hydrogen. Okay, so these are the clues that we are getting as we are moving forward. Next, 3 moles of D. So D is what? D is a salt of an acid. Sorry, salt of this particular compound. Okay, then 3 moles of D reacts with PCl3, gives 3 moles of the compound with molecular formula HOCl. Okay, so this is forming HOCl and E is formed as a byproduct. D is reduced to A with lithium aluminium hydride, followed by hydrolysis. Write the molecular formulas of compound A, B, C and D. So if I'm getting HOCl, okay, oh sorry, this one is so this is like this. Okay, so that means D must be HCOOH. Okay, D must be HCOOH. Then E will be byproduct here, H3PO3. Next, C will be what? If this is aldehyde with a without any alpha hydrogen, so this is HCHO. Okay, if this is HCHO, then this one will be what? This one will be HCOO. Sorry, so D is acid, then this one has to be an alcohol, right? So A will be CH2OH, sorry, CH3OH. Okay, and D is definitely HCOOH. Then if I treat CH3OH with CH3COOH, like for the esterification, you will get CH3, C double bond O, and then CH3 here. Okay, so these are the structures of A, B, C, D, E. 5 structures. If you find properly, you will get 5 marks. Next, we will move to 2025 examination 2 question. The first question is identify A, B, and C in the following reaction. So this one is your Gattermann. I'll take different pen. So this one is your Gattermann reaction. So this one will give you what? CHO. Okay, and then concentrated NaOH, it will undergo Cannizzaro reaction. So you will get one product is the alcohol, which is CH2OH, and the other product will be COO minus Na plus. Next, what is the composition of Tollens reagent, and write the reaction of it with the aldehydes. So Tollens reagent is the freshly prepared ammonical silver nitrate solution, and it reacts with AgNH3 whole 2 plus and 3OH minus to give you salt of acid, and then silver precipitate 4NH3 and 2 water molecule. Next, we'll see the second question from this chapter. So explain Itard reaction with an equation. So we have already discussed this question. How will you prepare acetamide from acetic acid? Write the equation. So if you treat acetic acid with ammonia to give you ammonium salt, which is then further heated at higher temperature, it will give you acetamide, and this is the reaction. Between SCHO and CH3CH2, which one will undergo aldol reaction? This one will undergo aldol reaction because it has alpha hydrogen. Now next question from this one, that is among acetaldehyde and benzaldehyde, which one undergoes aldol condensation? Explain its aldol condensation with an example. Okay, so acetaldehyde will obviously undergo. Why? Because it has an alpha hydrogen, and then you have to write down the reaction for this one. Stephan reaction with suitable chemical reaction. So here nitriles are converted to aldehydes. So you have to explain the statement, and then you have to write down the reaction. And here the reagent used are SnCl2 and HCl. Next, we will see question number 12. Now, compound A with molecular formula C7H8 on heating with alkaline KMnO4. So again, I have C7H8. That gives me a clear indication that it has to be, so I'm doing here A part, it has to be toluene, right? C7H8. Okay, so this is molecular formula A. reacts with alkaline KMnO4 and then further acidification produces B. So this one will give me COOH, which is B. Okay, now compound B on heating with ammonia at high temperature gives you compound C. So if you heat it with ammonia, you will get here CONH2. Okay, next we have write the structures of compound A, B and C. So this will give you 3 marks. Next, whether aromatic carboxylic acids undergo Friedel-Crafts reaction, the answer is no. What is the reason for that? COH group is an electron withdrawing group, so it will decrease the electron density in the ring, so it will not support electrophilic substitution reactions. Okay. Next, moving to amines chapter question. First from model question paper, which type of amines answers for carbyl amine reaction? Explain this reaction with an example. So first of all, primary amines will answer, and when it is heated with chloroform and alcoholic KOH, it gives you isocyanide, and this is the reaction. Okay, so writing this one, the statement and the reaction gives you 3 marks. Identify compound X and Y in the following reaction. So if you see, first of all, X will be your benzene disonium chloride, because here we are having diazotization reaction. Okay, now when you treat it with a Y, what will give you iodobenzene? So it has to be Ki. Okay, next moving to model question paper 2, explain carbyl amine reaction. We have just discussed this question already, right? This question we have already discussed. Then if you have treated with HbF4 plus NaNO2 plus copper, so here you will get nitrobenzene. Okay, and you have NaBF4 plus N2. Next you have IUPAC name of 1, 2, 3 carbon amine, so it is propanamine. Okay, now we will see model question paper 3, explain Hoffman bromamide degradation with chemical equation. So Hoffman bromamide degradation, when you have amides are heated in presence of bromine and aqueous NaOH, it gives you primary amines with 1 carbon less. Okay, so that is your Hoffman bromamide degradation. Next, coupling reaction of benzene with aniline. You have to write the statement and then the reaction, and IUPAC name of the given compound. So you can see 1, 2, 3, 4. So I have N diethyl, okay, butane 2 amine. Okay, now next one we have 2025 paper question, carbyl amine reaction with suitable reaction. Already we have discussed conversion of aniline to benzene disonium chloride. Explain the conversion of aniline to benzene disonium chloride with equation. So I'll just write down this equation once again. So if you take aniline, okay, and you treat it with what? HNO2, then you will get benzene disonium chloride. Next question is, among aryl amines and ammonia, which is more basic? So obviously ammonia is more basic. Why? Because it is having in case of aryl amines, the lone pairs of electrons are delocalized, involved in resonance. Okay, whereas in ammonia it is not happening. Next we have 2025 examination 2 question, write the equations for the conversion of aniline to 4-bromoaniline. Only equation you have to write down. So if you do direct 4-bromination, then 2,4,6 you will get tribromo. So first of all you have to protect this NH2 group by acylation. After that you have to do bromination, so bromine will be added at para position, bromine with acetic acid, and then if you do hydrolysis you will get back your NH2 group here. Okay, next we have, how do you distinguish between primary, secondary and tertiary amines using Hinsberg reagent? So first of all, Hinsberg reagent structure you should remember. Primary amine will give you benzene sulfonamide, which is soluble in alkali. Secondary amine will give you N-dialkene benzene sulfonamide, which is insoluble in alkali. And then tertiary amines will give you, it will not react at all with the Hinsberg reagent. Next we have, write the chemical equations involved in Gabriel phthalimide reaction. So these reaction step you have to write down, all the 5 steps should be written. Name the reducing agent most preferred in the conversion of nitrobenzene to aniline and justify your answer. So here we used Stephan reaction, and the reagent used is FeHCl. And why it is used? Because the iron scrap which is used help in the production of FeCl2, and HCl is liberated. So with very less amount of HCl we can actually carry out this reaction. Next we have biomolecules. So first of all, model question paper 1 question is, draw the structure of maltose. Very important. Why does it show reducing property? Because it can have free aldehyde group at carbon 1 position. Next, what are fibrous protein, and name the protein present in hair. So these are long thread-like proteins that provide structural strength and support to the cells and tissues, and they are insoluble in water. Next, keratin is the example of this one. Next, we have water reducing sugars, and write the Harvard structure of lactose. So reducing sugars are those which can reduce tolerance and fillings reagent, and this is the example of lactose structure. Hormones are needed in adequate quantities in our body, give reason for that. So it is because they have many functions in the body, like maintaining blood sugar level, responding to external stimuli, and so on. Next, what is the backbone of DNA? So backbone of DNA is the bond between between the nitrogenous bases, the hydrogen bond between the nitrogenous bases. Next, we have model question paper 3. Glucose is a monosaccharide and an aldohexose. Which oxidizing agent should be used to bring about the oxidation of the aldehyde group present in the glucose? Means only the aldehyde group. So for that we have to use the bromine water reagent and write the chemical equation. So this is the chemical equation for that. Two forces which stabilize the secondary and tertiary structures are your hydrogen bonds and disulfide linkages, van der Waals forces, and electrostatic forces. Any two you can write down. Name the type of linkage present in dinucleotide. It is phosphodiester linkage. Next, we'll see question number 4 here. Amylose and amylopectin are two components. Write any two difference between them. So here we have 4 points. Any two you can write down. List any two nitrogenous bases found in both RNA and DNA. It is adenine and guanine. And name the enzyme that is used to catalyze the maltose into glucose. That is your maltase. Next question is, what is peptide linkage, and draw the structure of glycine alanine. So peptide linkage is the bond which is formed between, is an amide linkage formed between the COH group and the amino acid group NH2, and here there is a glycyl alanine form. This is the formation of the bond. You can check this also. Next, write the chemical reaction for the 6 carbon atoms in a straight chain. So that is reaction with HI. Then for the presence of primary alcohol group, that should be your reaction with like gluconic acid. Like for the primary alcohol group, you have to react, you have to oxidize it with a strong oxidizing agent. So we have to use here concentrated nitric acid. Okay. Next, name the disease caused by the deficiency of ascorbic acid, that is vitamin C, and the disease caused is scurvy here. Next one, we have draw the Harvard structure of maltose. So this structure you have to draw. What is globular protein, and give an example of it. So are those proteins which are compact and spherical in shape and soluble in water. Example are hemoglobin, insulin, albumin. Name the nitrogenous bases present in RNA but absent in DNA. That is your uracil. So students, these were the most important 5-marker questions. Then after section D comes the section E, which is the numerical part, and I have made a detailed video on most important numericals. The link of this video will be there in the description section. You can check from here the most important numericals and practice them. Okay, so these are the overall, I can say, chapter wise most important questions, repeated questions. So do not miss these questions at any cost. Okay, thank you so much for watching, and all the best for your exam.